Welcome, everyone. It's the Crypto Lark, and I'm very excited to have on today Andre from Fantom. Andre, how's it going?
No, it's fantastic, man. Thanks for having me. I'm always amazed with the excitement in which you can start these intros.
Well, I'm always excited because there's always a lot of exciting technology happening and a lot of exciting implementations. And you guys who are at Fantom are doing some really, really great things. Now, just before we do jump into this, I just want to give a big thank you to the guys over at Fantom for helping to support the channel by sponsoring this interview. It really helps the channel out a lot. And I'm very excited to talk with the guys at Fantom. So, Andre, I think the first place we really need to start off is, what is Fantom? What are you guys doing?
I mean, there are so many bloody blockchains, right?
There's a lot of them.
And at the core of it, unfortunately, Fantom is just another one of all of these blockchains. So that aside, let's jump to what's the special sauce. What's the differentiation? So Fantom started with this, and it originated out of Yonsei University. It was a pure research project, Yonsei in South Korea. And it was this idea about asynchronous BFT consensus. Now, without going into too much technical details, which we can unpack later if we want, it's basically a way to use to spread information across a network fast and reach consensus on that information. So a traditional BFT system, just to give a quick description of it, let's say you have a network of 20 participants. A traditional BFT solution would be I ask each of the 20 participants, what do they think of this question, yes or no? I then collect the votes, all of the yeses, all of the nos, and then I tell the network again what were all of the yeses, what were all of the nos, and then everyone with that information can make the decision, was it yes or was it no, based on the majority of people. The traditional problem with that is you need a constant synchronous communication with people. So I have to be communicating with all 20 at the same time to get that information. That's synchronous. Asynchronous, all it does is means I can talk to the one person, then to the other one, then to the other one, and I don't need to have all parties at the same time, which just makes it slightly more fault tolerant. So that's the core, really all it is. It's a faster, more fault-tolerant way to do traditional BFT solutions. So that was the original concept. They then did the math proofs, they then did the MVP, and then we implemented it into code. And that was the original start of the Fantom project, and why they initiated was just because of this consensus mechanism they had that allowed a faster BFT mechanism. Since then, it's obviously expanded quite a bit. It's grown into a traditional blockchain organization, traditional smart contract support. On the smart contract side, you've got all the usual buzzwords: formal verification, verified computing, blah, blah, blah. I mean, there's more detail in the white papers than we need to discuss here.
But you guys have all the bells and whistles for smart contracts. That's
yeah. You've got the usual important ones coming out now. Look. So at the same time, they are exciting because I mean we've got Professor Bernard Schultz. He's down there at University of Sydney. I mean he is one of the forefathers of programming languages. So he's one of the literal best in the world in this field, and he is very passionate about Ethereum and the Ethereum ecosystem. Passionate, not necessarily in a positive sense. There's in the one meeting, I remember when I first met him, he told me that when he first looked at the Ethereum VM, it reminded him of someone that coded a VM that's never looked at a VM before. So
Shots
fantastic
fired.
guy.
Shots fired.
Yeah, very strong opinions. I was a little bit shocked by it. So him coming from that background has been wanting to do a distributed VM for a very long time. And he worked closely with Mike. We worked closely with the Yonsei guys. So just a fantastic relationship to have there. So they're doing it on the programming languages side. We've got Professor Byrne from Yonsei, who's doing it on the compiler side. And he's one of the guys that wrote the original comparisons between stack and register based VM. So again, fantastic person to have on board. Kampa and them that are working on the verified computing with Isekai. They built their own zero knowledge proof system from the ground up. Again, beautiful to have. And maybe to take it away from tech and make it a little bit more tangible. The reason why we're very excited about the distributed computing side is again, looking at Ethereum quickly, Ethereum always had this dream of being a world supercomputer. So the goal is that it can leverage the combined computing power of all of the nodes in the network. Proof of work, unfortunately, is a single source of origination. So only one node in the network can provide the proof of work for the block. So that means that it's only executing on that one machine. And then all other machines, to arrive at the same state, they have to execute the same execution set. So that means so if I had an execution 1 + 1, the dream is that I can do that 11,000 times because there are 11,000 nodes in the network. The reality is that 1 + 1 is executed 11,000 times because each node has to do it. And that becomes very expensive. We see problems on execution, we see problems on time, and a lot of other circumstances. But now, the reason that has to happen is because that's the only way for each node to arrive at the same state. When you start talking about verified computing, then you no longer have to do 1 + 1, because you get an output signature that proves that the execution ran successfully, and you get the output. So then all I have to do is I check the output. Is it the correct signature for the circuit that executed? And if it is, then I can apply the state. So now all of a sudden, thanks to verified computing, I can actually start parallelizing all of these extra concurrent executions, and I can actually leverage the power of the network.
So this is essentially going from like 11,000 to like 1.
Yes. So now only one has to execute. You still add a little bit of multi-party computation because you still want some fault redundancy. So if the one fails, then a second one at least executes. So, but that's normally some constant K that you set for the network. But so even though that's not even, and it's not the primary research of Fantom, that's its secondary most important part, but to me, that's still a very applicable one. And in all honesty, I got involved to bring it a little bit more practical again, because the ABFT consensus, so before this, we've had Raft, we've had Paxos, I mean, we've had distributed consensus for years, but they're all leader-based systems. And one of the areas where I'm quite heavily involved in is distributed consensus and localized clusters. To give an example of that is if you take automated cars. So right now we're still using a traffic system. So you have a stop sign and you have a go sign. So when it's red, the cars stop. When it's green, they're allowed to go. But this is a highly inefficient system. When the cars are autonomous and they're capable of communicating to each other, then you can imagine taking away the robots and just having the vehicles tell each other when they're going to pass and when they're going to intersect. And all of a sudden, what's normally a stop-go intersection now becomes a very high-velocity, fluid movement thing with cars constantly moving through. But to be able to do that, they need to be able to reach localized consensus in a distributed cluster, because there's not a single leader for any of the vehicles. They're communicating to each other about their position, and the rest need to be able to make decisions on their position in a secure, trustless fashion. So all of a sudden, this ABFT solution, which is great to apply to blockchain, and it still has its values there, is on its own a fantastic mechanism to allow things like autonomous cars without traffic systems. So my excitement definitely comes from using the consensus in distributed environments, equally as much as using it in blockchain environments. So I think that's often where Fantom does get a little bit of a bad rep, because it is a very researchy project. I mean, there's good biz dev, and we'll unpack that later as well. But it started with very strong research fundamentals, then moved into strong tech fundamentals, which they have now as well, thanks to the team that's been brought together. And now it's applying that to business fundamentals. But strength-wise, I'd definitely say it's research first, tech second, and development third. So I'd say that's really the two key components that differentiates Fantom and makes Fantom secret sauce. And those are going to be the two big things that we'll see as a driving force when Mainnet is launched.
Very, very cool. And I'm glad you brought up one of the use cases, because it's super interesting for me where we're going in terms of technology and the actual applications of those technology. Everything we've just talked about there, I mean, that's super interesting. But most people just want to know that their car is not going to crash into another car, right? And that's why it becomes so important that we do have this technology that just works. It's just good. And that taking the time to make good tech, that matters. It really does. And it's good that you guys are taking that time. And so I was looking at some of the use cases that you have that potential for. I mean, it's not just autonomous vehicles, right? It's about healthcare, the environment, smart living, smart cities, right? And let's just, as an example, can you expand a bit on the idea of smart cities, for example? How could we imagine, Fantom running a smart city? What would be some applications that would actually be happening?
So I mean, your primary starting point, and this is actually a little bit more generic, even so than smart cities, but data share is the key problem that you're actually solving. Because for a smart city to unlock its value and be called smart, it needs a lot of information to be transmitted by a lot of different areas. So you need waste management to be reporting on current levels. You need traffic management to be reporting on current traffic flow and current density. You need homes and their IoT devices to be reporting on temperature, on doors open, close, all of these things. So it's about getting to this point where if it's starting to rain outside, the heater in your home goes on, and because your heater goes on, that talks to the electricity grid that then manages that across whatever traffic grids or waste management grids. It depends on city per city. So problem number one is just facilitating a mechanism that all of this information is available, and that's technically not a difficult problem to solve. On an implementation level, it's a difficult problem to solve because you have so many different parties and so many different moving parts. But just transcribing that information as a transaction onto the chain, that's a problem that any blockchain can solve. So that's step one. So for that, it's about actually facilitating the integration components more so than the overall solution, because traffic management aren't all of a sudden going to move their systems 100% over to blockchain. I mean, they've been using these systems for years. It's well tested. It's proven itself. It works. So
well enough,
they're not
anyway.
going to switch over that. Yeah. So, but they're definitely not going to switch over to experimental tech. That's for sure. What they are willing to do is they are willing to at least take the data that they have and put that on as well. So that's step one. Because now you've got this central. Ironically, central repository of data, even though it's in a decentralized fashion, that's available to anyone to subscribe to. So as an example there, one of the differences we're building into the Fantom chain as well is this notion of selective data consumption. So right now, if you look at a traditional, again, we look at Bitcoin or Ethereum or something, each transaction has to be transcribed and confirmed by each node. So to give a practical example to this, let's say back when Tron was an ERC20 and EOS was an ERC20. Now, if EOS all of a sudden gets a lot of movement traction on its ERC20, it fills those blocks to the point where Tron can't do anything anymore because its transactions have to wait in back of line. So even though they're two completely separate systems, and what's happening on Tron does not affect in any way what's happening on EOS, they're impacted by each other. So the first change, and that's not even on a processing level, that's also on a data bloat level and a bunch of others. So one of the first things we had to do there was create a subscription-based system. So if I'm waste management and I don't care about traffic management, I simply don't subscribe to traffic management data sets. I keep my nodes lower and I keep my processing speed higher, even though the data is available. So let's say in 6 months from now, I do need it, I can subscribe to it and catch up and sync to the current state. So there's a lot of small niche little things you have to start doing when you start looking at smart cities, because problem number one is the data bloat. There's just too much information that compacts too quickly, and you need a mechanism to archive and to subscribe and to limit them. So those strategies are in place. The other thing is obviously high throughput. I mean, if you start talking about IoT devices, you're talking about billions potentially transactions that are coming through in a minute or an hour, or dependent on what kind of reading frequency you have. So high frequency with low latency is again important, which luckily that's the ABFT system. So it's a nice solution. But maybe to make it a little bit more practical, it's a little bit boring, but it's the valid use cases. So the one we're busy with right now with WeGo, which is Sol's smart city collaboration, is a simplistic complaint management system. So it's You're driving down the road, there's a pothole, and you simply submit that there's a pothole at that location. So, I mean, it's not fancy, it's not sexy, but it transcribes that information. It means multiple municipalities can subscribe to it and actually get the information. And you can start attaching very strong SLAs and, you know, response times and feedback and all of these things to the solution. So it speaks towards, you know, the classic tenets of what makes blockchain a little bit different than a database, and that is the fact that you have this extra transparency, you have this immutability, and you have this security. And that's what they want in a system like that, because you don't want independent agencies to be reporting, oh no, they fixed it at this time, but actually it was 3 days later, you know, and all of these kinds of things. So having that in real-time actions is what adds value there. That eventually expands to a lot of stuff. I mean, people always say smart cities, and you kind of think about this like, you know, year 3000 wonderful cars flying around.
Land of the future.
Exactly. And I mean, we're very far from getting there, but I think a lot of people, when you start using smart city nomenclature, they start thinking stuff like that. When really smart city right now is just about, let's facilitate and digitize as much data as possible, and let's make it available to as many organizations as possible. Because one thing, and that's why we're targeting the traffic management guys a lot, specifically because once that data is available and once that data is freely available, the things that other people might come up with is what I'm really interested in, because there's a lot of really smart solutions out there, but access to data is a problem. So once you transcribe it and you make it available, then I'm really excited to see actually not what Fantom facilitates and builds, but what other people can build with that data and do with that data. And I think that's where the real smart city starts coming in, when you start having the actual consumers integrating and building with it. Because again, if it's just this closed loop smart city, or if it's just the different government departments interacting with each other, then you're not really unlocking that value. I mean, we saw the boom that happened when we started having peer-to-peer, and we started having the Ubers and the Airbnbs of the world, and this was because of people-to-people interaction, not B2B or government interaction. Anyway, I've rambled on for a very long time, but that's what we're doing technologically, practically, and looking forward in terms of smart cities, definitely.
That's pretty cool, actually. And it's like you said, it's not potholes aren't super sexy, but it's a start, and that start shows the potential of the technology, and it shows that, you know, later on when the next ministry or whatever is looking at this, they go, hey, that's already been done. This has been working for a year now, and it's had good results, so therefore maybe it's something we can get into as well. Just in terms of scalability, I mean, Fantom is a DAG, so it theoretically very, very scalable, right? So let's just imagine Sol, the year 2150, or let's go Sol next year even. Let's year 2020. There's going to be all these smart devices, all these cars, all these things communicating with each other. I mean, can Fantom, when it gets to mainnet, of course we're still on testnet, but when it gets to mainnet, is it going to be able to run the smart city of Sol if it has all its IoT devices and things like that?
So I mean, now we're talking about frequency, and it's always a question of how. Actually, we're talking about transactions per second. I hate talking about transactions per second.
Transactions per. How big is your transactions per second, Andre?
Look, I have such a disdain for it, partly because there's no agreed metric. Like, if there was an agreed standard that we all measure TPS by, I would be happy with it. Hyperledger is actually doing a standardized testing solution now for EVM-based chains, which I'm heavily promoting, because I'd like there to be a standard in the industry. So right off the bat, let's say every single device, every single IoT device is transmitting at one reading every 100 milliseconds. So, I mean, you're already talking about 10 million plus transactions per second. Will that be manageable via a single chain? No. The clean answer is no, it's not. Realistically, okay, so maybe a little bit about how it works. So the whole, okay, so let's say you have one node and there's 1,000 nodes in your network. So you're limited then by the amount of transactions that originates from this one node. the other 999 nodes in the network aren't actually contributing throughput. So they're actually just making the network slower, because how long this transaction takes to reach finality is based on how long it takes to propagate through the entire network. So if you have 10 nodes, it's going to be fast. If you have 100, it's going to be slower. If you have 1,000, slower, and so forth and so forth. Now, you get a little bit of an advantage because of how gossip propagation works. So, 1 tells 2, 2 tells 4, 4 tells 8. So it does speed up, and you start having this like log-in medium that you hit around here. Anyway, but that aside, that's the propagation problem. But now let's say each node in the network was participating transaction origination. Then you're actually increasing throughput, because each one is building off on the same leg, and that means you've got more transactions and more packets going through the system. So if you can equally distribute transaction origination and keep the network graph in some kind of elegant mechanism, then yes, you can keep growing throughput, because if there's a new area, we'll drop a new node there. All of those new ones talk to that node, and they interact there, and they send their transactional throughput, and that'll keep scaling. It does have an upper limit, though. I mean, there are limits to the size of a transaction we can send via any given network infrastructure. And there's physical limitations towards how fast it can propagate. We have a speed of light constraint. Yeah. That's simplistic.
We haven't got over that yet. We probably never will.
No. So we're not going to go to infinite numbers. We're not going to go to millions. I mean, in all honesty, I don't think we're going to break
transactions per second.
No. In all honesty, we'll end up. Current tests and benchmark and our testnet show us that we're going to end up somewhere between 18,000 and 22,000 transactions per second. But now already very happy with it, and it's a good solution. But now that's where you start looking at what is the specific solution you're deploying, because even though so you have this idea of a top chain, and that's the primary one, and that anchors sort of all important data. Then you have this idea of subchains. So in traditional computing, we do exactly that. I mean, Facebook doesn't have a single server that everyone talks to. It has localized servers in areas that are spoken to, and they don't immediately talk to the same database. They talk to their own databases, because they assume you don't really need the information from the other people, like what some guy in the US that I've never met before posts versus what my neighbor posts. The neighbor one I need to know before that one. So that gets synchronized later, and it's not that important. So you start employing the exact same strategies. This isn't new technology. So you'll deploy in the exact same mechanism. So the traffic department will have their own little localized chain. And these are in blockchain terminology, they're essentially side chains. To me, they're really just sharding. No, I shouldn't use the word sharding, because then people think it's about sharding consensus again. But it's data scale sharding. It's the terminology in traditional technology in any case. So by using that, you increase and you increase and you increase your throughput by doing more and more deployments. So what we're doing right now is we're doing specific regionalized deployments for specific departments, and then rolling that data up and pushing it into the chain, because at that bottom level, now you have the security that this happened fast, it happened in real time, and everyone is happy. But that data isn't necessary to be accessed in high frequency with the overall system. So then you anchor it back into the original one. So it does mean that for me as, I don't know, private security, it takes 3 times as long to get the traffic management results than it does for traffic management, but it takes between 700 milliseconds to 1.3 seconds for traffic management to get it, which means I'm going to get it within 2 to 3 seconds, and that's still within any measure of SLA for a response time or a reaction time or anything like that. So the infinite scalability, which I hate to say because nothing is infinitely scalable, not even traditional systems, but arriving at the upper bounds of scalability is achieved via traditional load balancing mechanisms, just like we do with web servers today. The core technology just allows those localized clusters to be able to interact a little bit faster. Because in all honesty, it's not the TPS I'm excited about. The real thing that makes ABFT fantastic to me is the fact that its finality, which again is very important because you don't get finality in traditional blockchain solutions, but its finality is reached as based on the speed of propagation in the diameter of the network. So even if you had 100 nodes or let's say 100 nodes, you'd still be reaching finality sub 1 second, because that's where the user experience problem comes in. That's the I want to transfer something to you and I want immediate gratification around it. I don't want to have to check in 15 minutes from now and then in 30 minutes from now. So it's a lot more about that I think is good to the solution, because there's mechanisms to scale throughput. There's less mechanisms to increase that finality sector, because we get it in traditional systems because you have the synchronous connection of incoming transaction into API into database returns results, API returns results, and you have this immediate synchronous validation of what you did, and that's a key component that's missing in traditional implementations of blockchain. So having that in, it actually adds a lot of value to these solutions. Again, I go off on a lot of tangents, so when I do, feel free to tell me to shut up.
You're all good, Andrew. It's really interesting, actually. I'm sitting here like, that's right. It's interesting stuff. But we're going to move on from the kind of tech heavy stuff and actually start to talk about. I want to know what Fantom Pay is. So I've seen this. Can you break it down for us? What are you guys doing with Fantom Pay?
All right. So Fantom Pay originally started just as a dApp to prove micropayments. That's really all it was supposed to be, because that's obviously a big area where low finality and fast confirmation speed and high throughput is important, because then you can do things like go buying a cup of coffee at Starbucks. So we built those rails, we built the dApp on top of it, and it's just a dApp on top of the Fantom consensus engine. So it's not actually as important as everyone's making it out to be, but it's cool. So
dApps are cool. I like dApps.
But at the same time, before we invested too much energy into it, we went the traditional route of focus groups and consumer feedback. So we got a bunch of different focus groups, we got a bunch of different consumers, and we asked them, would they be willing to spend their crypto to buy a cup of coffee? The result was nearly unanimous in that no crypto holder wants to spend their crypto to buy a cup of coffee. They think of their crypto like an investment. It's shares to them. Just like you wouldn't use your Apple stocks to buy a cup of coffee, they don't want to use their crypto to buy a cup of coffee. So here we had this Rails that facilitated microtransactions, but no one actually wanted to use it, because I just want to hold my crypto and make lots of money in the future because Moon and 100x and blah blah blah, add in all your usual garbage. Mm-hmm. But that was the start of it. But now we had these Rails, and we wanted to see how are these Rails applicable and what can we do with them. So since Fantom Pay, there's branched out quite a few different subunits that leverages the same technology. So, because one of the things a lot of the groups we were interacting about, specifically Fantom Pay and integrating that into their ecosystems, accepting it as a merchant or peer-to-peer or whatever, they were very excited more about loyalty and reward points and all of these things, which are really just ERC20 tokens in an Ethereum sense. So we then used Fantom Pay to become a wrapper for these loyalty and merchant and payment utility tokens, so that these merchants can sign it out into their own networks. They have their minting rules and whatever they want to do, and they assign it, and then these tokens use the payment rails. So this allows you to redeem your vouchers or actually pay for it at a till point, or so it adds this extra layer on top of the original payment solution, and that's how it was getting a lot of traction. And then on the other side, we had the fiat on and off side. Not into crypto, just traditional spend. So, traditional credit card with traditional fiat that you load that you could spend in a shop. So the other thing we did there was now you've got this card and you swipe. So we looked at the top-up model for Fantom Pay. So our top-up model coffee costs $2.50, it rounds up to $3, and that extra 50 cents goes into Bitcoin or Ethereum or Fantom or whatever. So it's passive crypto investments essentially for micro investments. Fantom Pay's Rails against facilitated this, so it was a nice little niche. So we plugged that in, and that's currently being played with and tested as well. But I mean, so the innovation team are doing a lot of things around Fantom Pay, and they're playing a lot with it, but the technology team isn't that involved with it, because the tech side of it is finished. You know, I mean, it's facilitating fast transfers from A and B, it's facilitating exchange swaps, and it's facilitating tokens that live on top of it that can do the same functionality. So as a technologist, you know, I'm not particularly excited about it because there's again no sexy tech involved. Practically, the innovation team are doing a bunch of stuff. They've got the Fantom merchant stuff running. They've got all of that. The loyalty and the merchant stuff are actually now being used by here in South Africa and Africa, a few of the local banks to start playing around with stable coins. So they're actually using the infrastructure to have their own custodian on and off ramps. So they maintain that side, and then they just mint the token. So they're using the same technology to build their own stable coins, which I do enjoy that part, because the custodianship that we have to build there is quite entertaining. What else is happening on the pay side? I feel like I'm missing something. Oh, so the other thing is Freedom Bank. It's this mobile first digital bank. They wanted to facilitate crypto payments as well. But they do a top up model. So, you know, you can liquidate your crypto into your card and then swipe with your card. So they're building it off of those rails as well. So we're doing quite a bit of work with them. So that's quite cool. And I think that's it on the Fantom Pay side.
That's pretty cool, though. I mean, it's just important to have those kind of things being built, because it just shows that there's these applications that people can be using. And even if it just serves as a proof of concept, and it's not a proof of concept, people are actually using it, but even if it only had served as a proof of concept, well, that's important in itself, because it shows that we're not just a sexy blockchain here. We've actually got stuff that's happening on top of the blockchain. Now, I want to follow up with that about the Fantom Enterprise Alliance. So there's already some amazing partners with this. You mentioned one earlier, which is WeGo, but we've also got like Oracle and SoftBank and quite a few others. Can you comment on what these big enterprises are doing? I mean, how are they actually collaborating with Fantom in the Enterprise Alliance?
Sure. The Oracle one is actually the easiest one of the two. So Oracle have got a fairly comprehensive blockchain as a service solution. Their primary focus right now is Hyperledger. They've had the same issues with throughput and transactional volumes that simply weren't high enough for their clients. So they were looking for a higher throughput solution. So they started interacting with Fantom. We are actually currently adapting Hyperledger to talk via Lachesis, which is the consensus mechanism. So that Hyperledger uses that same throughput model. And then the other thing we're doing is we're also moving the Fantom blockchain to be on an API and RPC level compliant with Hyperledger. So then Oracle keeps doing what they're doing. They just swap out Hyperledger and instead put in Fantom, and then they offer that as a blockchain as a service solution. So that's cool. What we're busy doing there. Well, it's not that sexy, but yeah, straightforward.
Well, but it is because it's an important partnership to have, right? That's an important thing to be coming forward. So, and what about SoftBank?
Okay, now SoftBank. Well, so it's actually more on the POS bank side. They're the biggest POS solution provider in South Korea, in Seoul. And they actually just want to accept crypto payments. So they want to, anyone that has their software installed, so any merchant that has their software installed, they want to give that merchant the option to accept crypto as a payment mechanism. Wow. I'm the merchant, you've got your little terminal there. Normally you'd say pay by credit card or cash, and then you'll have pay by FTM. Select that, gives the QR code, the other dude scans the QR code, it does the payment, and that's it. So all we're doing is actually we expose APIs for them that they integrate with, so that they can see if the balance has changed and if it's finalized, and then we give them a few pings when the transaction has occurred, and the rest of the stuff they're doing on their side actually. So I think that's quite a lucky one for Fantom, because normally normally it's Fantom that has to do all of the work to facilitate the client, and in this case, they're actually doing most of the dev work to integrate on that side. That was supposed to already trial in February, but they've had a code freeze for some reason. I'm not sure why. So they've extended that, I think, until middle of this year. I mean, I'll follow up again with the Korean team how far that is, but that's what they're planning on doing. So it'll the plan is to accept a lot more than just Fantom. So that's why we've got wrapped B2C, wrapped ETH, all of those kinds of things to allow people to pay with that as well. And that's actually where the custodian technology comes in, which is a different side of the tech. That's something that Fusion Foundation, I don't know if you know about them, they're actually building, and then we're using the technology from their side. Basically, all it does is it allows distributed custodianship of assets. So instead of, if you look at something like IDEX and you want to trade with a B2C pair, which obviously you can't do because there is no B2C on Ethereum, they'll have a custodian that takes the B2C. They'll then issue wrapped B2C on the Ethereum network, which is just an ERC20 token, and now you have your B2C pair. This actually allows you to on Fantom chain, or in their case Fusion chain, control the actual assets on the other chain. So my wallet on this blockchain actually owns the B2C on that blockchain. So that custodianship allows you to start doing payments like that. We do still have a wrapped version, because the wrapped version facilitates that low latency immediate transfer, which is the user experience side. But that's then signed with proof keys to prove that the underlying asset can still move without being interrupted. So there's a mechanism to protect that. So yeah, that's it for Oracle and POSBank. So Oracle is the blockchain as a service solution, and POSBank is accepting payments via their POS terminals.
That's pretty cool. That's pretty cool, actually. I mean, just again, this is bringing crypto to the real world. And I did want to follow up a little bit about Korea as well, because obviously a lot of the dev team is in Korea. So is there like a big, I mean, you mentioned you're working with some smart banks in Africa, which is really cool, but is there like a big Korea focus, or is it really just focusing on a global market in terms of who you're looking for in terms of clients?
So primary, I'd say if you break it down, the most active region right now for business development is definitely Korea. Second, it's followed by Australia. And then I've now only recently started with some stuff here in South Africa and Africa. So yeah, Korea is definitely the primary focus. Most of the work is currently happening there. That's where most of the partnerships is, most of the relationships, and a little bit more on the Asian side, I'd say, because there's also a lot of good relationships in Singapore and Japan, nothing in China. But yeah, predominantly it's 80% Korean biz dev focused.
Very interesting. And just as a
please.
Just as
I just wanted to mention it's
go on.
Sorry, man. No, I just wanted to mention that it's Wigo as well in Korea that's getting a lot of focus. So when we mentioned that, I mean, it's Oracle Korea, it's Wigo, it's POSBank, it's all the Korean entities. It's not their global entity. So it's definitely a strong focus there.
Now, just as a final question here to kind of wrap up the year moving forward, I mean, currently we're in testnet with Fantom. So when's the mainnet coming? And aside from the mainnet, what can we expect from Fantom in the coming year?
So mainnet is officially scheduled for Q3 of this year. Realistically, we only have to finish the proof of stake implementation and then Atropos selection. So I'm expecting it to actually happen quite a lot sooner. We want to go into sort of beta mainnet around end May-ish. So I'll probably expect mainnet soon after that. We'll let it run for a month or two with a few security-based hackathons just to make sure that the consensus security mechanisms stay true, and then launch post that. And then from there the focus needs to shift to ecosystem development. It's facilitating people to build on top of it, make it easy to build, introduce that to new environments, because at its core, something like a blockchain is analog to a operating system and or a database, depending on which one of the two analogies you want to use. So often, and I like the database analogy because there's fantastic tech out there today that runs on a database, but you don't know it. I mean, original Facebook wasn't MySQL. No one knew it wasn't MySQL, but you knew Facebook. So Fantom sort of has to facilitate that same role, where it's not necessarily the one that people know about, but there's a lot of really cool products running on top of that. So that's why there's definitely a strong dual approach there. Approach number one is around facilitating our own business development and getting integration partners. You know, we go Postbank, the ZAR network stablecoin, all of these things. And then once Mainnet is live, so that's easy to do now because we have all of the development skills and expertise. Once Mainnet is live, we'd like to shift that focus away from you know, Fantom as the primary builders, and instead people that want to build as the primary builders. So it's a lot more focused on, I don't want to call it, I guess it's community development, but I mean, that's not the right terminology I'm looking for. It's developer facilitation. You know, it's making sure that we have good documentation aligned. We can help people build easily and fast, and all of those things. So that's up till Mainnet. The focus is definitely Mainnet itself. Post that, we'll be releasing some of our own products, the smart city stuff, the payment solutions, and again, all open source, so people can build their own solutions on top of that. And then after that, the focus will definitely change to a lot more community building and marketing and outreach.
Very, very cool. So much exciting going on. It's really cool to you know, dive in and just see people who we've worked, you know. By the way, Andre, I don't know if you noticed, there's this kind of bear market thing going on, and it's, a lot of cryptos have gone down in value and all this fun stuff, but like, it doesn't matter. People are out there building. They're out there building great technology. They're getting amazing partners, and things continue to move forward regardless of whatever price may be up or down on any given day. The tech's here, the tech's being built, the tech's getting real implementations, which is super exciting.
Yeah, I mean, so it's short term versus long term, right? That's what it comes down to. I mean, you can look at the 3 month, the 6 month projection, and you can be really depressed about what happened in the last year. I myself, fortunately, I'm not an investor, so I get to sit on the sidelines and smile.
It's gonna go down.
Still, I feel bad for the people that obviously are heavily invested in it. But yes, we can see that a lot of the Fugazi and garbage people have been wiped out. We can see there's a lot stronger focus on tech and product development and adoption for the long-term outlook. Because where previously everyone were just building blockchains for the sake of building blockchains, now we're building blockchains to facilitate very specific solutions. And I think that's a very good pivot in this industry. So I'm expecting great things over the next, 3, 5, 10 years. Even if I don't expect great things over the next, 3, 6 months.
Long term indeed. Andre, thank you so much for coming on and telling us what's going on over at Fantom.
No, it was awesome, man. Thanks for having me.
For sure.